we hail, we love.
Good day, my fellow students. I'm happy to welcome you to our another session of our class. This is our 5th class in this course, and we are going to consider a new making progress in the new study sessions. And I'm hoping that you people are really catching up and you're working with us. I hope that we're all in the same page. And I want to believe you people are taking good advantage of this opportunity to study more at home. Let me still reintroduce myself. That my name is Dr. DAUDA YUSUF, and I will still take you around in the next study session that we are in, which is our study session 5. And in this study session 5, we shall be considering simultaneous equations. We are already done and learned about equation system. So here our learning outcome shall be to explain the concept of simultaneous equations, and we are also going to look at the difference between simultaneous equations and graphical equations, and we shall be solving simultaneous problem using the eliminations and substitution method. I will also provide a graphical solution to some simultaneous equations. So in introducing this course, we said the term simultaneous equation refers to the conditions where two or more unknown variables are related to each other through an equal numbers of equations. Unknown variables are related to each other through an equal numbers of equations. A simultaneous equation is two or more equation which contain more than one letter term. We will look at the steps and different methods involved in solving simultaneous equations. So, introduction to simultaneous equations. Simultaneous equation refers to a condition where two or more unknown variables are related to each other through an equal numbers of equations. To solve a simultaneous equation problem, follow these two highlighted steps that I'm going to give now. First, the first step is that eliminate one of the later terms and find the value of the remaining letter. Second step, substitute this value into the original equations to find the value of the other letter term. So, a common way of solving simultaneous equation is by equating the coefficients. Before we do that, let us just have a look at a relatively straightforward simple equation. The equation we are going to look at is, maybe let's say 4x minus 1 is equals to 3. The above expression is a linear equation. It is a linear equation because there is involvement of x to the power of 2, y to the power of 2, or xy, or any higher powers of x and y, thus making our equations linear equations. So let's look at the example. Let's say 4x minus y plus y is equals to 3 plus y. Here you will now have 4x is equals to 3 plus y. Now let's take 3 away from each side. If you take 3 away from each side, you will have 4x minus 3 equals to y. So we will now have this gives us an expression for y. So y is equals to 4x minus 3. Suppose we choose a value for x, say x equals to 1. Then y will be equal to, y is equals to 4, open bracket 1, close the bracket, minus 3 equals to 1. Suppose we choose a different value for x, say x equals to 2. We will still have y is equals to 4, open bracket 2, close the bracket, minus 3 is equals to 5. Suppose we choose another value for x, say x is equal to 0, we'll have y is equal to 4, open bracket, close the bracket, 0 minus 3 is equal to minus 3. So for every value of x, we can generate a value of y. I hope you know this. Similarly, consider the example below that we have 5x minus y is equal to 6 and 2x plus y is equal to 8. For the first equation, the solution becomes 5x minus y is equal to 6 and y now will be equal to 5x minus 6. In the above equations, y-intercept is minus 6 while the slope is 5. For the second equation, the solution is 2x plus y is equal to 8 while y is equal to minus 2x plus 8. The y-intercept in the above result is 8 while the x slope is minus 2. So for this set of equations, there is both a single combination of values for x and y that will satisfy both. Either equations considered separately has an infinitude of value. Let's say in bracket x and y solutions. But together, there is only one solution. Plotted on a graph, this condition becomes obvious. So you can see it from this graph. It's well straight that, okay, y is equal to 5x minus 6 is equals to, you have 4 and 2 in the bracket there. The same thing, y is equals to minus 2x plus 8 is equals to 4 and 2 in the bracket, in the y-axis and the x-axis. So note that each line is actually a continuum or point representing possible x and y solution pairs for each equation separately has an infinite numbers of other pair x and y solution. There is only one point of y and x linear functions 5x minus y equals to 6 and 2x plus y equals to 8 intersect, where one of their many independent solutions have both equal equations, and that is the point where x is equal to a value of 2 and y is equal to a value of 4. Usually, though, graphic is not a very efficient way to determine simultaneous solution set of the equation. It is especially impractical for systems of 3 or more variables. So let's use a substitution method of simultaneous equations. Let's take example 1. We say x plus 2y is equal to 20, equation 1. Then 2x minus 2y is equal to 4, equation 2. Let us continue with our equations above. Making the subject of the formula, we say 2y is equal to 20 minus x, and y is equal to 10 minus 0.5x. So now substitute y equals to 10 minus 0.5x into the equation 2. You will have, what we will have now is going to be 2x minus 2, open bracket, 10 minus 0.5x, we close the bracket, which is equal to minus 4. Now that we have an equation with just a single variable, which is x in the bracket, we cannot solve it using normal algebraic techniques, which is 2x minus 20 plus x is equal to minus 4. Combining the like terms gives 3x minus 20, which is equal to minus 4. Adding 20 to both sides, you will have 3x equals to 16. So you divide both sides by 3, you will have x is equal to 5.3. Now that x is known, we can plug this value into any of the original equations and obtain a value for y. That is, x is equal to 5.3. Substitute it into the equations y equals to 10 minus 0.5x. Y is equal to 10 minus 0.5, open bracket, 5.3, close the bracket. So you have 5 equals to 10 and minus 2.7. So therefore, y will be equals to 7.3. I want to believe you are following. So, substitution methods of simultaneous equations. Example, you solve this simultaneous equation by, let's take this example 1 again, that say 2x plus 5y is equals to 27, which is question 1, and 2x plus 2y is equals to 12. Let's take this is question 2. Let's find the solution to this example. In both equations, notice we have the same number of x, 2, which is 2. Make x the subject of the formula in equation 1. So when we say 2x is equals to 27 minus 5y over 2. Therefore, therefore x is equals to 13.5. X, is equals to 27 over 2 minus 5y over 2. Therefore, x will be 13.5 minus 2.5y. And this can now be our equation 3. Substitute this value into equation 2 to get the value for y. We will have 2 open bracket 13.5 minus 2.5y close the bracket plus 2y is equals to 12. Therefore, we have 27 minus, so if we multiply it, it will give you 27 minus 5y plus 2y equals to 12. If you collect the like times, it will yield minus 3y is equals to minus 15. Hope you get it. So we are now going to say, okay, because it's minus 5 plus 2 will give you minus 3y. Let me give the explanation. And here now with 27 minus 12 will also give you 15. So that is why we are having minus 3y equals to minus 12. So we have, you dividing both sides by minus 3. If you divide both sides by minus 3, all you will have, since it's minus 3, minus go with minus, 3 goes with minus 3. So what we will end up having is y is equals to 5. I hope this is quite clear and simple. Now we impute y equals to 5 into our equation 1 to get the actual value for x, or we can impute in our equation 3 to make things faster. In order to facilitate easy understanding, we will consider both options. So let's impute y equals to 5 into equation 1. So we'll have 2x plus 5, open bracket 5 is equals to 27. And so we have 2x plus 25, because 5 times 5 gives 25 equals 27. So when we have 2x is equals to 27 minus 25, the simple answer will be 2x is equals to 2. If you divide both sides by 2, you will have x equals to 1. I think this is express. So we're now imputing y equals to 5 in equation 3. You will say have x is equals to 30.5 minus 2.5 open bracket 5. So we'll have x is equals to 30.5 minus 12, because it's 2.5 times 5 will give you 12.5. And so 13.5 minus 12.5 will also be x is equals to 1. So both options gives us the same value for x. So I am hoping you are following. So eliminations, addition and subtraction method of solving substitution equations. The addition and subtraction method for solving substitution equations is also called the elimination method. It involves adding or subtracting equations from one another and even multiplying each equations by a constant if need be. While the substitution method may be the easiest to grasp on a conceptual level, there are other methods of solutions available to us. One of such methods is the addition or subtraction method, whereby equations are added or subtracted from one another for the purpose of cancelling variables terms. This is done when the coefficients of y or x in each equation are the same and the signs of y or x are opposites. Then add or subtract each side of the equations to eliminate y or x, as the case may be. So let's demonstrate in the example from our next slides. So let's see solving systems of a linear equation by addition and subtraction. So in this next slide, let's say example 1, when we have 4x plus 2y is equals to 14, equation 1, and 2x minus 2y equals to 6, equation 2. Notice that y in both equations have opposite signs. Thus, adding the two equations together eliminates y, thus resulting in 6x equals to 8. We can solve the above equations completely. We can solve the above equation completely. That is 6x is equals to 8. So x now will give you 1.33. I hope you get it, because if you say that 60, if you divide 8 by this, it will just give you 1.33 and so on and so forth. So this cannot be our equation 3. So to find y, we need to impute x equals to 1.33 into the equation 1. So if you check our equation 1, we have 4 into, since the x is 1.33, we put it there in the bracket, 1.33 plus 2y equals to 14. So when you say 4 times this will give you 5.32 plus 2y equals to 14, and then if you collect the like time, you will now have 2y is equals to 14 minus 5.32. So 32. So that will say 2y is equals to 8.68. So y is equals to 4.34. The solution to the above problem is thus: x is equals to 1.33 and y is equals to what? 4.34. Do you understand? Yes, I want to believe you understood well. So let's take another example 2. So example 2 here, we are saying 4x minus 4y is equals to 12. Equation 1. 3x plus 4y is equals to 8. Equation 2. Subtracting equation 2 from 1 gives us x is equals to 4. That will become our equation 3. We impute x equals to 4 into equation 1 in order to find y. So if you are to find y, we are saying x open bracket 4 minus 4y is equals to 12. So 4 times 4 will give us 16. Minus 4y is equals to 12. So if you collect the like time, it will give us minus 4y is equals to 12 minus 16. That will give us minus 4 is equals to minus 4y is equals to minus 4. So you divide it through by minus 4, you will just end up having y is equals to 1. Because 4 into 4, 1y. 4 into 4, 1. And minus cancel minus, it goes. So next, we now impute y equals to equation 1. Y equals to 1 into equation 1 to confirm the value for x. So we say, okay, 4x minus 5y is equals to 12. So 4x minus 4, open bracket 1, which is the y, is equals to 12. Here we now say, okay, 4x is minus 4 is equals to 12. You collect the like time, 4x is equals to 12 plus 4 will be 16. So 4x is equals to 16. Say x now will be 16 divided by 4 will give you 4. So x is 4. So you can see that the value for our x corresponds to the initial value of 4, thus confirming that our result is in line. Another style of solving using the additions or subtraction methods is presented below. And let's move to the next and see. So let's check this example 1. That 7x plus 2y is equals to 47. This should be our equation 1. And we have 5x minus 4y is equals to 1, which is our equation 2. Notice that the coefficients of y in equation 1 and 2 are not the same, thus making it impossible to eliminate them through additions or subtraction. The techniques used in this case is multiplying equation 1 with the value of y in addition in equation 2, and multiply equation 2 with the value of y in equation 1. So based on the equations above, we multiply equation 1 with 4, which belongs to y, in equation 2, and we multiply equation 2 with 2 which belong to y in equation 1 to get a uniform model. So let's see that if you open bracket, 7x plus 2y is equal to 47, close the bracket, times 4. So then we say 5x minus 4y is equals to 1, close the bracket, times 2. So if we multiply, you have 28x plus 8y is equals to 188. That is equation 3. Then 10x minus 8y is equals to 2, which is our equation 4. So eliminating equation 3 and 4 by adding the two equations together yield what we call 38x is equal to 198. If you divide 190, sorry, it's equal to 190. If you divide 190 by 38, it will give you x will be equals to 5. Now that we have a value of x, we can substitute this into equation 2 in order to find y. So substituting this in equation 2, we'll say, okay, 5x, 5x minus 4y is equals to 1. So 5, we put 5 again in the place of x, 5 in the place of x, which is the answer to x, minus 4y is equals to 1. So 5 times 1 will give you 25, minus 4y is equals to 1. So if you collect the like times, we have minus 4y is equals to minus 24. Divide both sides by 4. So what we have there will be y is equals to 6. Because minus cancelling minus, 4 cancelling 4, 4 into 24 will give us 6. Thank you for understanding. I want to believe and hope that you people are following this lecture passionately, and God will see you through. Thank you. See you in our next class, and we hope to be happy with each other. I want to believe we are already transforming to mathematical students. Well, have a wonderful day.